Fourier's transformations first. This is the definition of Fourier transformation over here. And you can see we're going to start with a rect function. The name is self-explanatory. It's a rectangle, basically. You have 0 over here in a rectangle. Now, as you know, an integral is basically area. So over here, if there's nothing here, then we can presume that even if you integrate anything here, it would be 0. So we could change the bounds to t divided by 2 and negative t divided by 2 because that's where everything is, and we can get rid of everything else because that'll just be 0. But that said, now we have a way to solve this. So we're going to just solve this because this is just basic integration. It is inverse power rule, basically. And you keep on going and you realize you have this format over here in the end, and you go to Euler's formula to get a sign format over here. And then with that Euler's format, you just keep on going, simplifying until you get here. And we realize a sinc function. A sinc function is defined by a sine parentheses x divided by x. This is called a sinc function. So we go over here and see that this is sinc. With that said, you have this. And this is a one-to-one domain, so you can actually get an inverse Fourier transfers back to the time regime over here, rectangle, but that's later. Anyways, we move on to the next question, which is going to be the Laplace transformation, the one that almost everyone loves because it's a simple. It's a unilateral Laplace transformation. This one is negative because of the table, actually, honestly, everyone loves it. But anyway, negative infinity to infinity, we have t to the e to the negative t plus 1, which we're just going to use integration of parts like crack. This integration by parts is going to be used a lot. And basically, you choose whatever. So this turns to these two integrals. So we go this one, I believe, goes over here in the first one. We see that there's a t over here, that t is u, and then we take the derivative of that, which is du equal dt, and then we have e to the negative st, which is going to be dv, and we take the integral of that, which gives you this. That's all we did. And we did our second one with the other one. This one is this one, and we expand both of them out sooner or later to this format over here. Once we expand it, we realize that this goes to 0, and this goes to 0 because it's this negative s, and e to the negative x goes like this to 0. And then 0 over here is t over here. You see that t, that equals 0, so you get those two out, leaving us with this integral and this integral. With those two integrals, we just solve them. And we get 1 divided by s squared plus 1 divided by s plus 2 squared. And that's just simply it. And I know my type version is better, so I'm just going to clear that. Okay,